Okay. Starting recording, it says. Okay. Okay, it's starting. Okay.
Yes, sir.
So one question, sir.
Yes, please. Yes, yes.
So this is the column has the heading as Y, and we will understand, but this may not be understandable like when we look at in isolation, right?
Isolation in the sense, Y in the sense, Y is the conventional notation for dependent variable.
Got it. Like, should we give a little more recognizable churn underscore Y, something like that?
Yeah, yeah, you can do that. Here you have to just within brackets, you can just type it as churn underscore Y or something. That's okay. That's okay. Okay. It's just a label that we are giving. Whatever you understand, you can just give.
Okay. Meaning to ask, will we be doing more such things for the other columns also, other features
Yes,
also?
we have to. We have to. We have to. That's why I've taken this messy data, and I showed you initially, if you recall, in the Excel, I've just colored some of these as numeric, so colored others as, colored others in orange, because we have string data. We have taken care of only, dependent variable, which is string. What about these variables that you are able to see, like contract is there, streaming movies is there? Ideally speaking, we have to do it for each of these variables.
Okay.
But we don't have the time to do each of these things. So this is where pandas function comes into picture. It is called as get dummies. So I will be showing how we can sort of convert a set of independent variables to dependent variable. As you can see here, modeling is just a tiny piece, right? It is not difficult at all, but the difficult part is the pre-processing part. Right. So this is what you can always emphasize even during the interview, right? As much as possible. Okay. We have transformed. Okay, let's just do a df.info very quickly. Right, we have the y variable, which is integer. We can go ahead and work with the y variable. Okay. Now, what we need to do is basically separate out the independent categorical variables for conversion into numerical. Ganesh, since you are asking me this question, this is what we are going to do. We will be separating out all the independent categorical variables, string data or categorical variables, so that we can convert them into numerical.
Sure.
Okay, so if you can see here, all the variables which have not colored are basically okay. When I say okay, basically they are more or less numerical. But the problem comes with all this. Look at these variables, partner and such things, and even gender for that matter. So effectively, we have 3 plus 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 categorical variables, which we need to sort of convert to numeric variables, correct? If we use that transform label encoder, it will be a bit of a problem. So we don't want to use that transform function. What we will now be using is another function, which is called as get underscore dummies. Let's go ahead with this. First, let me just separate out these variables. We can see here. All right. df.lock. We are going to use the .lock function. Sorry. Yes, yes, yes. I'm just pasting this code, guys, because it may take some time for you to type each of these things. Chat. And then Control V. You can just use this. So these are the variables. We can use the variable lock function, correct? From df.lock, I'm isolating what all variables you can see here: gender, partner, dependents, all the service related variables, paperless billing, payment method, all these things. All right. You can see here, I'm just calling it as X underscore categorical, right? So that it's easy for us to recognize this is the list of my categorical variables. Just let me know in case you're through with this. Done. X underscore categorical. All right. Now, what are we going to do? Let's just display the top 5 rows of this categorical list. You can see here, almost all of them are character variables. All these are character variables which we have captured. If we have missed out, we can just use this as a label anywhere here and rerun the code. Right. So check the shape. So 15 columns and 7043, that makes sense. This is what we have, right? Okay. Now, simultaneously, what we will do is we will separate out the numeric variables, correct? Variables like senior citizen, tenure, monthly charges and total charges. These are all numeric variables. We can use the .log function, right? df.log function, right? And we can just take out all the numeric variables. So the entire data set has been now split into 2 portions, right? In Excel, I have used pink color to denote all the categorical variables. Numeric variables are not harming me in any way, so I will not, be disturbed with these numeric variables. But if you want to just quickly check the shape, look at this. All of them, these are the 4 variables which are numeric, and they're all the form of numbers. Not a problem at all. There's no problem at all with these variables. Now you see here how we can, in one shot, very simple function, convert these categorical variables into dummy variables. So we have to get, numbers. We have to get numbers. Sorry. So since we want to convert it, I'll be using a function which is called as pd.get_dummies. So this is the function. This is a good function, guys. You can expect this question, right? Right. And you're going to pass this X underscore category, correct? I've already created this X underscore category as an object, which has all the string variables like gender, partner, dependents, etc., etc., etc. So all these variables I'm passing under the get underscore dummies function. Get underscore dummies function. Right. So what, after converting this into numbers, we can just call this as X underscore num1. Right. X underscore num has senior citizen, tenure, monthly charges, and total charges, which are all numbers anyway. So I'm not too bothered about them. I am bothered about these string data. So this is my X underscore num1. So just sort of preview, you can just do use a head function. Just see here, what are you getting? See, originally, how was the data? You can see here gender, you had one variable. Now it has broken down
So the
into
screen,
gender.
if you changed, it's not visible to me.
What is not visible?
Are you in a different screen, sir, now?
No, I'm okay. Let me just share it once again. I'm using Python. I've shared Python only.
Yes, the screen is visible.
Is it visible or is it not visible?
It was visible,
Okay.
sir.
Okay. Now are you clear, Ganesh? Are you able to see it?
Yeah, I saw up to that xnum, the previous one. This get dummies I did not see. So.
Okay.
Okay, continue, sir.
Okay, so I was just saying that once you create this dummies function, you can see here, it has created two variables, one for females and one for males. If you ask me personally, we should be slightly careful. We should drop one variable. Right? If a variable has 2 categories, one dummy coding is sufficient. If a variable has 3, 2 dummy variables are sufficient. N-1 variables is what it should create. Right? If it has 5 categories, 5 minus 1, which is 4, it should create 4 variables. Correct? See, if a person is female, this actually information is captured, correct? First person is a female, so it is coded as 1. Second person is a male, therefore it is coded as 0. Third person is a male, 0. Fourth person is a male, 0. Fifth person is again a male, 0. Then if you look at the second variable will actually be redundant.
बता दो.
Can you please go on mute? Yeah, please. I request you to put yourself on mute. Right. So see here, we have 41 columns which we have created. But yeah, how many times we should use that? Usually get underscore dummies use conventionally is used for independent variables. That transform is used for dependent. That's why I said initially for a dependent variable label encoder. For this get underscore dummies. Right, we'll have this, but at a later stage, please feel free to remove all these unwanted variables. Right, unwanted variables we can just filter off a lot. Okay. Right, I hope you're able to appreciate the data pre-processing steps, guys. Processing steps, right? So now what we will do is our job is to simply concatenate num1 and num. What is this num1? The newly created dummies. What is this num? The 4 original variables. We will just be concatenating it. How? Simply use pd.concatenate function. pd.concat, right? Open parentheses as a list. You can pass the objects x underscore num1, put a comma and then say x underscore num. It will concatenate this comma axis is equal to 1, which means we have to concatenate it vertically. We are not appending, we are merging.
Can you go back to x num1 once again? What is the x num1?
Get underscore dummies on the list of categorical variables, put it as x underscore num1.
Okay, and what is x num?
Xnum is these 4 variables, original variables, senior citizen, tenure, monthly charges and total charges, which are already numeric. These 4 variables are already numeric, okay. So don't need to worry about them. Just call them as x underscore num. X underscore num1 is after converting categorical string data into numbers. I'm storing as x underscore num1. Once I've gotten the dummies, what I'm doing is basically I'm concatenating these 2 objects, and now my x variable is ready. X is the set of independent variables. My y is anyway ready, waiting for me. I can just basically regress them. Right, even if one variable is here and there. Yesterday I was getting a lot of errors. Night when I was just checking this code, we can just check this once again. Okay, right, whether we have done all the steps or not. One variable was missing, it will be a problem. So now my list of independent variables, right? Final set of independent variables, independent variables. This is the final set of my independent variables, 5 rows and 45 columns. All are numbers. You can just visually inspect them. All of these are numbers. There's not one single categorical variable. So I hope this is clear, guys. And please, in the interview, please highlight these things, guys. In the interview or anywhere else, right? Highlight what all steps did you take to convert string to numeric, and how did you concatenate it? Those sort of things, please highlight it. Right? Which function did you use? Get dummies function in pandas. Correct? Go back to the size of x number. Yes, 41. 3 plus 1, 4, right? Total charges anyway, we convert it to numeric. Total, yes. 41 plus 4 is 5. So 41 plus 4 is 45, sorry. Aditya, following me. Anish? Okay.
I'm good, sir. Yes.
Yes, Guru, you're okay? I'm just waiting for Guru. Okay, guys, now let us worry about the dependent variable that we have created. So So Ganesh, as you are saying, y may be slightly, confusing. Now this is your opportunity to create any other variable, right? Churn underscore y or churn underscore dependent, churn underscore numeric. But I'm just calling this as y because it is very easy to recognize y and x. Y is my dependent variable from a point of view of mathematics, and x is my independent variable, but you can label it however you want. The first two rows, if I recall, are non-churners, so it is coded as 0. Third case is churner, fourth is non-churner, fifth is churner. So this is just a preview we are generating. Our dependent variable is ready and our independent variable is ready. Here I will just say end of data pre-processing this. We were just doing data pre-processing and such thing, nothing else we have done. Okay, my spellings is wrong. End of. This is my end of data pre-processing. Now we are actually ready to build the model using this converted data. Yes, please. Why can't we remove water? Ideally speaking, you should, because it is redundant information. So it will lead to a lot of problems. You just drop off wherever it is not necessary. Okay, now we are ready to build this model using the converted data. So as before, now it is basically simple, right? Now it works just like your linear regression, train underscore test underscore split. Correct? You'll pass x and y. X and y are very easy to remember. I've given very, very simple this thing, labels. Test size is 25%. I'm taking as test, which automatically means that we will be training the model on 75% of the cases. Okay, so let us just examine the shape of each of these things, guys. First, let's examine the shape of train underscore x. Right, 45 columns, that remains the same. Correct. 5 to 82 out of 7,000. Sorry, approximately if you take 75% of it, it should come up to around 5 to 82. Right.
Sir, can you go up and show how we get x actually concatenation? I missed that part. I'm getting an error.
PD.concatenate. Azaz, are you following Azaz? I'm not sure if you're able to follow this.
Yeah, I'm getting that output.
I think yesterday, last class, we did linear regression, so it's based on the same thing.
Yeah.
If you have any doubts, please please feel free to stop me and ask me. Okay.
Sure.
Okay, sir. Okay. Are you done with this concatenate?
Right.
Okay. Shall I proceed?
Yeah.
Okay, guys, look at this, guys. X and Y, the argument should be the same, 5282, 5282. It's a good sign. And yesterday I was getting an error because I overlooked the presence of missing cases in test data. So 3 cases were less. Therefore, it will not agree. Okay, so it can't be the size of independent and dependent variable cannot be different. Correct? So now let us just make a move on to test underscore shape. Okay, let's just do a test underscore shape. It is 1761 and test underscore y. If I examine, it should be consistent. How much is it? It is 1761. 1761, 1761. Both of these guys are 1761 guys. So which means by and large, our logistic regression can be expected to work properly now. Right? So we have examined the shape, everything. Now let us instantiate our logistic regression model. Just instantiate. Right? Again, I'm doing the same thing from sklearn.linear underscore model, import logistic regression. In the case of linear regression, I said import linear regression, correct? So the object is saved as log here. So this is your logistic regression model. The object which we will be saving is called as log. It's just a short form for logistic regression model. L caps, R caps. Okay. So let's just make a move on from this. Let's just check if there are any missing cases in train data set, guys. What do you want? I'll show you. I'll show you. This is the one. From sklearn.linear underscore model, import logistic regression. L is in capital letters, R is in capital letters. Any problem? Import pre-processing, import metrics. Just copy paste this. Okay, I'm just pasting this. Execute this. Ideally, this should not make any difference.
This we have done in the beginning itself, no, sir?
Yes, but Guru was having a problem because he is not able to get this. He ran into a few issues in line number 42. So we are just examining the issue that he's facing.
Okay.
So like, why are we stuck right now?
No, there's a small typing mistake. That's why we just stopped.
Okay. Which one it's I am also doing just I didn't check it.
So are we on the same page till now, everybody?
Almost, yeah.
Okay, so
Yeah.
0, 0, 0, just examining there before we fit the model, just examine that you're getting all zeros, because even if one single variable has a missing case, we will not be able to fit the model. And I was repeatedly getting errors because of this variable monthly charges, not monthly charges, sorry, total charges, which I hope we have taken care of sufficiently. Now that we are getting everything as zero, we are good to go
So
to build
I'm
our,
getting total charges is 8.
8. So for me too, it is 8.
because see, you have missed out a couple of steps here. The steps, I think this is the one which we need to sort of focus on, wherein we have
I
said,
did that.
no, no, you wouldn't
I
have done
did.
it.
Oh,
No, please do this step again, convert total charges into numeric first, and then impute the missing cases, it will work.
sir, can you send it, please? I don't know how to copy it.
So this is the missing value imputation part of it first. Control V. Then total charges into numeric, control V. You should not have one single missing case, otherwise we'll have problems.
So one small doubt. So after converting to numeric only, we have to do the imputation, right? Or before?
Yes, yes, yes. After numeric, otherwise it will not understand.
Yeah, that's all.
That course is there, right? Course means literally we are forcing it to follow numeric. First convert it into number, then you can use this missing value imputation technique. I'll wait for you for a couple of minutes so that you can catch up, guys. Every column should be 0, guys, here. Please make sure that everything is 0 here. Aditya, 0. What happened? Same issue. Seriously, seriously. 0. 0, everything is 0. First is now, what is the guarantee that means in this?
Okay, sir, all good.
Yeah, okay. This one. Yeah, I do see this should be on. Um, huh? Wait, just 1 second. File. Just 1 second. 1 second, guys. I'm just sending this file to Aditya C drive users race method. Tell me. Oh, yeah, Aditya.
Are you sending to everyone?
No, I'm just sending this to Aditya because he is having a few issues with his code. If you're getting this 000, it's fine. There is no issue.
No, suddenly I don't see any output. Maybe I'll restart the kernel.
.ai03.
.ai03.
Reva.
Reva.
I mean race.reva.edu.in.
race.reva.edu.in.
I think that you can remove that.
Is it okay?
Yeah.
Adityan.
Dot.
Adityan AI, is it?
.ai03.
.ai.
Dot you can remove.
Okay. 1 second. It's C drive. Doesn't it? Okay. Just run the same thing, but just check the order. First, you should course and then impute the missing cases. First course, then impute the missing cases. I think the rest of us are okay, guys. Everybody.
We are in sync with what you are.
Yes.
Okay. Just that we have to get a 0 here. So let us just go ahead and you missed Aditya. Somewhere I think you missed one step. Just open that, run the same thing. Except that you have to change the file name. Path of the file. Importing. Okay, logistic regression, we have been able to fit the model. Now, once we have fit the model, the next is basically the logistic regression coefficient, right? So log dot coef underscore, right? So we are getting a lot of coefficients here. You can see here, like before, same way as linear regression, but we can't interpret it at this stage because variable name is not there. So we'll have to sort it. We'll do that. Log dot coef underscore. Whatever.
So what coefficient it is, sir?
You're getting with this code or old with this, right? Sorry, somebody asked a question. I was attending to Guru. Please tell me.
No, I'm asking, sir, what coefficient it is? Like, what is this value means?
I'll just tell you. Just give me 1 second. Just give me 1 second. What is this coefficient? That is what he's asking. I'll just show you. So basically, what we have to do at this stage is to label this. Okay, I'll just copy paste this code because this is slightly lengthy and you may miss out on these things. Please copy paste this. Still not getting it. Aditya, can you just share that code with him, Guru? Guru. I think you skipped a couple of codes somewhere. Okay, so far we are clear, guys, everybody. Right? We have to just put a label on this, right? And then we'll be in a better position to interpret this. So let us look at coefficient. Are you able to see this? So these are all each of our independent variables, and we have been able to generate the coefficients for each of these variables. These are all each of these independent variables. And for each of these variables, we have been able to generate a coefficient. Right? Let us just take a sample of this, right? Is the one. I'll just explain this, what we are trying to do here. Just give me 1 second. You send the code to him. Just open that and execute. Okay. Just specify the path for the file. Okay. Okay. Manish. Okay, 1 minute. Shival sir. I've anyway pasted this code. I pasted this code in Teams, so you don't have to copy this code. Line number 47. You can use it from Teams. Copy paste it. Done. Okay. So can you please see this, everybody? Right, this is the equation for logistic regression model. He has given h theta of x and all. Don't worry about this. 1 divided by 1 plus exponential of minus of beta naught plus beta 1 x. X is what here? My independent variable. It is x1, x2, x3. How many x's we have? We have 45 x's in our data set. So what this beta naught, beta 1, beta 2, beta 3, all these are nothing but the coefficients of each of these variables. To what extent is my dependent variable getting influenced by the independent variable? Now that is what we have generated. So to your question as to what are these coefficients? These coefficients are nothing but your beta 1, beta 2, beta 3, beta 4. You'll have as many coefficients as you have number of variables. If you have 20 variables, 20 coefficients. If you have 30 variables, 30 coefficients. Now, how do we interpret these coefficients? That is the question. So let me just come back to the code here. Let me show you the code once again.
So, sorry to interrupt. Is this the coefficient means the weight that we discussed in the slide. We saw some weight, right?
We saw some whiter.
Weight associated
Yes,
with the
yes,
input
yes,
variable.
yes, yes. You're right.
The
You're
same
right.
stuff.
It's weight itself. It's the weight. You can call them as the weight itself. So can you see some of these variables which we have sorted this quotient dot sort values based on ascend is equal to true. So from all the negative values, as you scroll down, you will be seeing a lot of positive values here, correct? So let me just take some of these cases. Here we have to do a bit of data cleaning here for gender, female and male. What do we see here? We have two variables. Let me just take one. Ideally speaking, we should go back and remove these variables like male, partner is equal to no, those things we should remove. So if you look at gender, you see a negative coefficient, correct? Correct. So gender is having a negative impact on propensity to churn. So wherever you see a negative sign, it means that it has having a negative impact. But if I scroll further down, you can see here variables like tenure. So if tenure increases, then the propensity of churn will come down because there's a negative sign. I can't say that it is increasing, it is decreasing by 6 units because the interpretation is not the same as that of linear regression. So I'm just saying whether it's having a positive impact or it's having a negative impact. If it's having a positive sign here, it means that it is positively driving one or the churn propensity. If it is if you're getting a negative value, it means that you are basically getting a negative coefficient. Right? It is negatively impacting the variable churn. So for example, monthly charges, correct? If the monthly charges increases, which means basically I'm using my whatever network provider, I'm using the service, and if the bill increases, if the charges increase, my propensity to churn will also go up because there's a positive number here. Correct? If the total charges increase, it means that the propensity to churn will also go up. Are you able to understand? Either it's having a positive impact or a negative impact. Couple of points which I would like to tell you here, right? And can I show you the Excel sheet and maybe show you through Excel sheet? Correct. If you take the sum product of each of these things, correct? If you just multiply the coefficient by the variable plus coefficient times variable. So minus 0.06 times female plus minus 0.05 times male. What if you just take the sum product, what will you get? You can get any number. Let me just show you. How do you interpret these numbers? That's what I'm just slightly getting into a tricky situation. So let me just open an Excel sheet and show you.
Sir?
Correct? Yes.
I'm very sorry to say, but the concept is not getting clear.
I'm clarifying it. Just give me 1 second.
Right, sir. Okay.
Very present for my last class.
No, but I went through your videos.
So that is the thing. See, there we interpreted the linear regression coefficients in detail. We interpreted. I think you missed that, and therefore it's a bit of a struggle for you to understand this. So there we spoke about beta coefficients and such things. Do you remember, guys? For each of you, for each variable, we'll be generating the beta coefficients, and based on those beta coefficients, we said that what is the impact of this beta coefficient on my dependent variable. This is the same thing here. So you can see the variable and the coefficient here. Let me just pick up this variable. Do you see tenure here? This is one of my independent variable.
Right, sir.
Are you able to see? So against tenure, do you see a negative 0.06? Are you able to see this? Yes or no?
Yes, sir. Yes, sir.
Against monthly charges, you see a positive number. Against total charges, you're seeing a positive number here. I am saying basically, how do you interpret this negative value? I am saying that tenure is my independent variable. This negative 0.06 means that if tenure increases by 1 month, the dependent variable comes down. Why is it? I'm saying that the dependent variable will come down because there's a negative sign. Dependent variable coming down means what? The propensity of a person churning will come down. So tenure is having a negative impact on your dependent variable. That's how we should interpret it. Now you look at the next variable, 43rd variable, which is monthly charges. So if the monthly charges go up by 1 unit, then the propensity to churn will also go up. Why am I saying it will go up? Because it's a positive sign. So if there is a positive sign here, this particular variable will have a positive impact on the propensity to churn. If you see a negative coefficient here, it means that increasing this variable will bring down the propensity to churn. Negative means basically inverse effect. If you increase one, the other will come down. If you see a positive number here, it means that both of them have a positive impact. If one increases, the other one will also go up. So that's how we can interpret each of these variables. Like, for example, I'm just reiterating the same thing. Monthly charges, it has a positive impact, which means that if you increase the monthly charges, if you increase the price of this particular service, the propensity to churn will also go up. So just watch out for the sign here. Is it positive or negative? Positive means basically it has a what? It's a direct effect. If you increase monthly charges, propensity to churn will go up. If it is negative, it means that basically you'll have a negative impact. It's something like, if I have to give an example, simple example of price and sales. If you make something more and more expensive, if price increases, sales will come down. Correct? If discount increases, sales will go up. The same thing here also. If monthly charges become more and more, if it increases by 1 unit, then the propensity to churn. Why am I saying propensity to churn? Because that is a dependent variable. We are trying to quantify the impact of monthly charges on the propensity to churn. So if you see a positive number here, it means that as monthly charges increase by 1 unit or 1 rupee or $1, the propensity to churn will also go up. Total charges increase, that will also your propensity to churn also go up. That is the way we can interpret it. I don't know if you've been able to understand or if you're more convinced. Sorry, if you're more confused. I would request you to just go to that linear regression and look at the output of it, and then come to logistic regression. Because I think I gave a detailed explanation for each of these variables with nitric oxide and such things there, right? If independent variable increases by 1 unit, what is the corresponding impact on the dependent variable? It is the same thing here. If independent variable increases, whether you'll see a positive impact on the dependent variable or not. That is what we are talking about.
Sir, I got the idea. Thanks for the clarification. Just one thing. So we discussed about increasing the monthly charges and tenure, all this. So if what will happen if I reduce it, like I'm reducing the tenure or reducing monthly charges?
Okay, so that's why I'm saying, remember the words inverse. If you see a negative value here, it means that there's an inverse impact. If you decrease tenure, then you will see a ulta. The propensity, if you decrease tenure, the propensity to churn will go up. Decreasing one will increase the other. Increasing the one will decrease the other. They are going in opposite directions. Right. If you see a positive coefficient here, it means that both of them are going in the same direction. If you increase monthly charges, propensity of churn will also increase. If you decrease monthly charges, propensity of churn will also go down. So there is a direct effect or there's an indirect effect. That's what we can say from this.
They're directly proportional then.
Yes, yes. In the case of monthly charges and total charges, they're directly proportionate.
Thank you, sir.
Okay. Guys, I just want to slightly get into a tricky situation. So please bear with me, try and understand what I'm saying, right? So in the case of, I hope you can see my Excel sheet, everybody.
Yes,
Right?
sir.
I'm just explaining the motivation for your logistic regression. Correct? We need the concept of your B0 plus B1x. What is this? This is the right hand side of linear regression. Do you agree? Right hand side, correct? You're just multiplying by the variable, correct? Let us say you get some number of 500. I don't know, you can take any number, any big number, small number, you can take this, correct? So this is your linear regression. Regression will generate the output as some number, right? It may be minus 500, 500, whatever it is, you'll get some number. Now, I'm just telling you what is the motivation for logistic regression. Correct. Henceforth, what we'll be talking about is nothing but the right B0 plus B1x. Can I take a negative sign of this? Control C, Control V, except for the fact that there will be a negative sign here. Make this a string so that it just takes it. Okay, is this B0 plus B1x? Correct. What is this? This will be nothing but minus 500. Whatever number you get, we'll be just taking the negative of that. Correct? You may have 100 variables here. Sir, B0 plus B1x, you have B2 plus X2 plus beta 2 into X2 plus beta 3 into X3. If you take some number, you'll get some number here as the output 500, 5000, whatever it is. Now what I'm going to do is, can I just pass this entire thing under the exponential function? Exponential of minus B0 plus B1x. Correct? If this is the label, what should I do here? Equals exponential of, you can see this function, just pass this value of minus 500 there. Correct? Are you able to get this, guys? Everybody? Correct? So what do you see here?
So
Don't you
it will
think
be
it's a very, very small number
point.
here?
Yeah, some
Exponential
point.
of minus, correct? It's a very, very small number. Can I add 1 to this number? B0 plus B1x. Correct? So which means effectively I'm adding 1 to this number in the numerator. Are you able to get this, everybody? So what are you getting? 1 into whatever this number is into 10 power 6. Correct? Now what I'm going to do is I'm just going to divide this entire thing. 1 divided by 1 plus exponential of minus B0 plus B1x. Correct? When I say 1 divided by this, I have to just take the reciprocal of the number above. 1 divided by this number here. Correct? How much are you getting here? Can I make this general? We started off with a number of minus 500, correct? Now you see here, you're just burning it, you're just reducing it to 1. Now this number is not interpretable. Minus 500, if it gives linear regression, I can't interpret it. So I'm just taking the right hand side of the linear regression model, which is B0 plus beta 1x. What I'm doing this is I'm attaching a negative sign here, that after attaching this negative sign, I'm passing it through the exponential function, adding a 1 to it. Why am I adding 1 in the denominator? Because the denominator becomes bigger. As the denominator becomes bigger, overall quantity will reduce. So that is what I'm doing here. So the moment you do this, 1 divided by 1 plus exponential of whatever is inside is nothing but the whatever is inside in the bracket is nothing but the right hand side of your linear regression model. The final result will always be between 0 and 1. Are you able to get this? Now, what is this? Is this not your logistic regression function? This is nothing but your sigmoid function. So this is the motivation behind getting a sigmoid function. That's it. The foundation is simply the linear regression itself, but that number is not interpretable, and therefore you attach a negative sign. Add a 1 to the denominator. The denominator becomes big. 1 divided by any bigger number, you'll still get a smaller number between 0 and 1. So yeah, I'm just clipping its wings. I'm not going to allow it to exceed 1. I'm also not going to allow the final value to be below 0. No matter what you pass into it, it will always be between 0 and 1, which is what we are doing here, nothing else. Is it clear, guys? Are you able to understand this? This is the function mathematical form which I was showing you in the slide in the morning. Aditya, Guru, able to follow? Yes, but usually, yes. Usually it will not be like such a big one. Therefore, if you observe the sigmoid curve, it comes very close to 0, but it usually does not touch 0. Same way with 1, it comes very close to 1, but it does not touch 1. It could be 0.000000000 some 0 and then some 0, 1. But we are saying it is going to 0, it is tending to 0, but not exactly 0. So this is the mathematical motivation behind the sigmoid function. I hope we are clear till here, guys. We have generated the coefficients and everything. Now the next stage is basically generating the model diagnostics. Okay, let me just come here. What do you want? The code, is it? There's one person who's just copying the code. Just give me 1 second, please. I'm just yes. Right. So variables we have generated the coefficients. Now the next topic here within this is basically model diagnostics. Let us do this model diagnostics. Let us simply call this as heading. OK, Control Enter. This is my model diagnostics. OK. So to generate the model diagnostics, basically, guys, what we'll be first of all doing is we'll have to use log.predict. Log is nothing but short form for logistic, right? Log.fit we have used, log.coefficient we have used, log.predict. Predict on what? Predicting on the test data set. So log.predict. Now I'm applying the model on the testing data set. I've built the model. At this stage, I'm applying the model on the test data set. Yeah.
Sir, one question here.
Yes, please.
Like we didn't check the accuracy, like validation and test. Sorry, train accuracy.
This entire accuracy business we will check under model diagnostics. I'm just generating the predicted classes and such things. Based on that, I will be able to generate the accuracy. So we are still not come to accuracy. We'll be coming to accuracy in another 5 or 10 minutes.
Okay.
Okay, what we are doing is even before I generate the accuracy, I have to score my test data set. Do you agree or not, guys? Right? I have to apply it on the test data set, generate the prediction, compare the prediction with the actual, and only then I'll be able to get the accuracy. Correct? So here I'm predicting or scoring my test data set. Right? That's what the predict does. So you can see here some of the predictions that the model is giving. Correct? This here, 0, 0, 0. So I think the first two classes have been correctly classified, if I remember, because from the Excel sheet, I remember the first two classes are no. The model also is predicting it as 0. The third class has been misclassified because the third class, if I remember correctly, is a churner, but my model is saying that it is a non-churner. So it has generated an array here. Correct? 0 means what? This is the predicted class for the first individual. This is what? Predicted as 0. Third also it is predicting as 0. Right? Somewhere here I can see 1. Right? So this is giving individual predictions. What I want is basically the aggregate value. Let us see how we'll proceed to get the overall accuracy and such things. Predicted classes dot size. So for 1761 samples, which is the test data set, we've been able to generate the predictions. Do you agree, guys? Let me just go back. If you see here, look at this test underscore x dot shape. We have said 1761 records are there. So for each of these test samples, I've been able to generate the predictions here. Correct? So it has generated the predictions. There are no problems with that. OK, let's just go ahead with this. Now, total number of positive cases in the test data set. I will be just printing the positive cases in the test data set. Right? How much is it? 434. One is the predictions, correct? Clear, guys? So far, we are just pulling out certain numbers here so that it becomes easy for us to understand. Positive cases in the test data is 434. You can see here in the code test underscore y, and then I'm using a filter test underscore y equal to 1. So we are just counting the number of test cases. And then shape is equal to 0. We'll just extract the rows. Guru, you're able to execute now. Working, right? Srivalsa. Finish. So far you're good. You're just extracting, right? Any concerns, please let me know. Aditya, done. Shall I make a move on? Finish. You want me to paste this code? It's done. Okay. Now let me just check the number of negative cases in the data set. You can just see here test underscore y. Same thing. I'm just copy paste the same code. Test underscore y equal to 0. You're just extracting the first argument. You can see here 1327 non-churners are there in the data set. 1327 non-churners are there in the data set. So if you want to just check, right? If you want to just check percentage of churners, what is the percentage of churners? All that you need to do is just type equal to. I've got 434 divided by 1761. Okay, maybe I have to remove. It is not Excel. It is 24% churners is what we have. 76% non-churners. Okay, now precision and recall. Let us just firstly print the overall accuracy of the model. Accuracy we are not able to generate, is it? Uh-huh. Okay, let me just try this. print metric dot accuracy. Remove this, please. Just ignore this. To do is from metrics, we'll be generating the accuracy score. You have to supply two arguments here, test underscore y, which is the dependent variable, and the object classes have the predictions. So when you are comparing the test with the actual, we are getting 81% accuracy. Overall, we are getting 81% accuracy. Are you clear with this? So far, we are clear. Overall, the model is around 81% accuracy. For test, it is good here. For a test data set, even if you're getting 65 to 70%, it is good. In the interview, you can say 70%, but in a real life situation, 65 and above is a good number. We are getting 81, not on training. On the test we are getting is a great achievement. It is not bad at all, right? Yes. Now, let us do one more thing here, which is to generate the confusion matrix. Is giving a overall level, right? At an overall level, it is giving me. But for each of the individual level metrics, I don't know what is going on. Therefore, we will just be generating the confusion matrix now.
So can you send this code, please?
One second.
Yeah.
Confusion matrix. Control V. Okay, just see if you're able to get this, guys. Are you able to get this matrix, everybody? I'll explain what is this matrix, right? First, generate this. Guru, getting this. Ganesh, Srivalsa. Ganesh, are you able to get this?
So can you send the file? I lost track somewhere in between.
What happened? Sorry. For me.
Can you please send this file?
Okay, Aditya is sending you, okay? Okay, so we have to understand each of these numbers, right? Shall we go ahead? Right? So it's a lot easier for me to explain this in Excel. So I'll just take one of your help.
Sir, one question.
Yeah.
See, what actually I was interested. I understand that we looked into training accuracy, but when we are doing the training, so that time also is it not required to check the accuracy, like training accuracy?
You can,
Like
but it is an academic. Now I got your question. You can look at the training accuracy also. But the training accuracy many times is immaterial because whether it is very high or very low, I cannot take it seriously.
No, I got your point. Now, some model, what will happen? We do validation also. So when you are doing validation and training, that time we should check the accuracy side by side, no?
No, what you're doing when we are applying the model and generating the coefficient for the confusion matrix, what are we doing? Are we not validating?
But yes.
So this is, see, why are we
No,
actually
no.
using the?
Yeah, sir. Sorry. I'll just put the question. I'll just complete my question actually. So my intention is to basically, actually, I wanted to come to that question later, but since we are discussing, I'll put that question like, how do I know my model is influenced by bias or it is overfitted? How do I know that?
So if you want to know whether your model is biased or not, then basically you have to compare the training accuracy with the test accuracy.
Right, yeah.
Generate. So for example, see here, what are we doing? Accuracy score we are doing, correct? Here, instead of test underscore y and comma classes, what you have to do is train underscore y comma classes you should give. That's it. Are you
Right,
able to
right.
understand this?
Yeah,
Train
I
underscore
got.
y comma
Yes,
classes. But
yes.
one more thing that you need to do here is basically this classes.
Will be
How does this
training.
classes? Yeah, this is log dot predict of test underscore x. So it is
Training.
generating the classes for the test. Here you have to pass the train data set.
Correct. Yeah.
So if you want to generate the accuracy for the training data set, instead of test underscore x, please pass train underscore x, capture it as an object as classes, then come down here and then instead of test underscore y and classes, please use train underscore y and classes. You should be able to see the accuracy level for the training data set.
So I wanted to ask you, suppose, how do I, first of all, how do I evaluate whether my model has been influenced by, it is a overfitted model or it is biased model, and what remediation or what kind of remediation I should take to correct my model? That was the question I wanted to ask.
Yes, yes. So this question I've again answered in detail in the linear regression model, wherein we generated a heat map and such things. And we sort of said that if there are variables which are heavily correlated with each other, independent variables which are largely correlated amongst each other, there is a good chance that the accuracy between training and testing will be, there will be a huge gap between training and test. If the training shows 90% accuracy and testing shows 70% accuracy, the difference between training and test, that is 90% and 70%, is 20%, which is in double digit. So if the gap is so high as 20%, your model is definitely overfitting. If there is overfitting problem, how do you address it? That is your question. So you have to drop a lot of variables which are redundant. For example, in this data set, we have to ideally drop a lot of variables. For example, let me just scroll up. Can you see this variable gender underscore female and gender underscore male? This is redundant information. One is sufficient. We don't need both. If you take females, don't take males. If you take males, don't take females. Similarly, drop one of these two variables. Partner is equal to no and partner is equal to yes. You can drop one of these variables. Dependent is equal to no and dependent is equal to yes. Drop one of these variables. So as you drop around, let's say 8 to 10 variables, your overfitting problem will greatly reduce. Correct? This is the hard route. If you want a shortcut method to reduce overfitting, there is an alternative method to logistic regression, which is called as random forest. Random forest as a technique can be used greatly to solve the problem of overfitting and such things. There's an algorithm which is called as random forest. You can use the technique of random forest to reduce overfitting. I'd like to again recall the discussion. If you remember, I said that there are techniques like elastic net, L1 regularizer, L2 regularizer. These regularization techniques are designed to take care of overfitting problem.
Okay, and L1 and L2 regularizer part of like which model, sir, or it is a general approach?
No, you're not very clear. Can you come again, please?
No, like this L1 and L2 regularization, it is a generic for a specific model or algorithm, or it is a generic.
L1 and L1 regularizer, L2 regularizer are generally used. They are generally used for classification methods, specifically for logistic regression method. Let us say you still are not able to solve the problem of overfitting, then the last option that you have is use decision tree.
What's a decision tree is like high chances for overfitting. Decision tree, no?
So just try it with decision tree. If
Yeah.
that does not work, you anyway have random forest. Random forest is the best when it comes to handling overfitting.
Mm-hmm.
Your go-to method would be your to just oversimplify. If you have to try 2 or 3 methods for overfitting, try random forest. That is the first thing, right? It is easy and the code is also simple. I think in 1 or 2 lines of code you should be able to you should be able to deal with overfitting using random forest. Second is basically you can use elastic net approach or your regularization approach, which I was just mentioning now, to correct for the problem of overfitting.
Okay, sir.
Okay. Now, okay, guys, I was just trying to interpret this confusion matrix. So just tell me, guys, if you're able to sort of see my Excel sheet. I'm just opening a blank Excel sheet so that I can just explain some of these things to you. Correct?
Visible, sir.
Correct. There are 2 categories in the data set. One is what is called as, or else from the confusion matrix itself, can you read out the numbers in the 4 boxes?
1189, 138,
1189. Okay.
138,
1,
38, 138,
138. Okay.
193,
193.
241.
4, 1. Correct. Along the row, what does it say? What is the heading in the row?
True 0.
No, wait. No, that's not what I'm looking after. So can you see here? Yeah, true 0 and true 1. Along the column, we have predicted 0 and predicted 1. Correct. So what you have along the column is nothing but your predictions. So this is, which means basically this is churn, sorry, non-churn, and this is churn. Correct. Similarly here, non-churn, and this is churn. This is true. The word true also means actuals here. Actual means what? From the data, what we have. So let me just sort of.
It is something like true, positive, false, positive, all those things, no?
Yes, you're right. You're right. Are we clear with this, guys? Let me just double check this. So true 0, 0 is nothing but non-churners. 1 is nothing but churners. So this is the actual category, right? And along the column, what do I have? Predicted category. So these are my predictions. This is the heading, correct? Are we clear with this? Right. Now, what is the category which is of interest to us?
Can you
Which
come the
categories
question?
of, sorry?
What is the question, sir?
No, which category at the end of the day, why are we building a model? To identify churn, correct? Not non-churners, correct? So churn
Yep.
category will be considered as the positive category.
Right. Yep.
Where is this? This guy is the positive category. So in the bracket, what you will have is the negative category. Correct. The leftover category must be negative, right? Non-churners, how do I call them? I'll just be calling them as negative here. And this is my positive category. Clear? So the question is, there are 5 important numbers I want to pull out from this 2x2 matrix. What are these 5 important metrics? Now, can you see this number? Actually, can I add up these rows basically? Can I add up the row and get the row total? Just get the sum of these two things, right? Let me just drag this. I'm taking the sum of these two things, drag it, and then add up these two things. Then you can just further add this up. This is your 1761. So in the data set, we have 1761, right? We have the row total, we have the column total, correct? Now, so I'm just going to call this. I'm just going to use green cell for this. I'm going to color it using green. You know why? Because actual is positive, predicted is also positive. Are you able to understand this? Actual is positive. Can you see here along the row? Actual is positive. My model has also correctly predicted it as positive. So this we use a terminology. It is called as true positive. The adjective true there means that the model has correctly classified churners as churners. Are you able to get this? So this number 241 within bracket, I'll just call this as TP or true positive. Did you get this, guys? Everybody? Understood? Yes, no?
Yes, sir.
Right now. So these numbers are changing, correct? Because I put it at TP, it is just changing. Don't worry about this. It's just the row total at the end of the day. Now look at this. Now actual is positive, predicted is negative. What does this mean? Actually, he's a churner. My model has predicted him as a non-churner. So he is
False
false.
negative.
So it's a false negative. So you have to basically call this number what? You have to call this number as false negative. Are you able to get this? Yes or no, everybody? Right? Now, just as you have true positive, also see this number. He is actually a non-churner. My model also has predicted him as a non-churner. You have to call
True
this
negative.
as true negative. Truly, the model is indicating a negative person is negative. Are we clear with this? Right? Next, what do you have? Positive, correct? He is actually a negative. My model is saying that he is positive.
False
So
positive.
what is the meaning of this? This is a case of Fn. So we have to call this as false negative.
Sir, false positive.
Sorry. My apologies. This is false positive. Are we clear with this? What is true negative? What is true positive? What is false positive? What is false negative? Right. Now, there are certain things which I'm going to write here. Overall sample size is how much in this data set?
1761.
Very good, 1761. Correct. In the overall accuracy metric, how much did you get? I don't know, was it to me or was it? So in the overall accuracy, there was 81% accuracy. That is what we got. But that overall accuracy is not a reliable metric. Overall is not a reliable metric. Can you tell me why?
Because it includes false positive cases, false negative cases.
Exactly.
Mainly false positive cases. Yeah.
So I'll just show you an example here. So in this data set, let us just take 10 cases, correct? 1, 1, 1. You have 0, 0, 0, 1, 1, 1, 1, correct? Are you able to get this? This is the actual data. Let us say my model, this is the predicted data, predicted. Predicted by whom? Logistic regression model. I'm just giving a situation here. Just think of this, right? If the model is basically predicting as 1, what is happening here? I'm predicting everything as 1. I'm getting still 100%. I'm able to sort of track all the churners. Don't you think? Don't you think it's correct? I don't even need your model. I'll predict everything as 1. So 1 versus 1 is correct. 1 versus 1 is correct. 1 versus 1 is correct. 0, you already said that I'm not concerned about zeros. So why are you looking at zeros? Don't worry about zeros. 1 versus 1 is correct. 1, 1
Yes,
correct. 1, 1. So it means that you don't even need a model. By random guessing also, you are able to do a good job. Then why do you need a model actually? Are you able to understand? So in this case, overall accuracy and such things will be
100%.
misleading as a number. You can't always look at overall accuracy. Overall accuracy, overall, the operative word being overall, you're looking at everything. I may not be interested in everything. I am interested in one particular category, which is basically the one category, the plus category, which is whether they are churned or not. Here is where we need to generate two important metrics. One is called as precision and the second one is called as recall. Please try to understand precision and recall. And the third one is what is called as F1. F1 you don't have to worry because it is generated or derived from these two itself. F1 is generated from precision and recall. The question is what is precision? What is recall? When do I use what? Correct. For this, I will be opening up a blog so that I can just explain this as to what is what.
Sir, is it that TPR and recall are same?
TP is used, total positive, TPR is used to generate your precision as well as recall.
So is that TPR and recall are same?
Yes, yes.
TPR and recall, how can it be the same? See, if you look at the formula here, recall is TP divided by TP plus FN.
Okay.
I will be using
Yeah,
TP.
TPR is
Yes.
precision.
For precision, I will be using TP divided by TP plus FP. So even before that, let's just look at some of these things. Can you just read this, everybody? Just go through this. Please read this at a very high level, get a feel of this. Right? Why do you need these things over and above accuracy? Correct. Firstly, what is the confusion matrix? We know this 2 by 2 binary classification. We have just now said this, correct? True negative, true positive, false negative, false positive, that we have been able to understand. Now let's understand the confusing terms of TP, TN, FN. I think this is clear, right, to you? TP, TN, whatever. Example, with the help of this 2 by 2 matrix, he's just generated some of these things. Correct? So you know this, right? Here he's saying 10 people. Look at this positive versus positive is the correct classification. So in our model, can you see this, guys? The greens. I'm just, coloring the greens. So overall accuracy of the model, if you want the overall accuracy of the model, all that you need to do is just take the addition of the diagonal elements. What is the additional of this thing? Diagonal elements 11, 8, 9. Take plus 2, 4, 1. This will be in my numerator. Do you agree, guys? Right? Just put a division symbol. What is the overall sample size? What is the overall sample size? Is it not 1761? Correct. So you're getting 81%. This is what your Python was also saying. So diagonal elements, sum of the diagonal elements divided by sum of each of the cells. That is your overall accuracy. Am I right, guys? Is this okay? This is the overall accuracy level. So just convert this into a percentage. Your job is done. Now let's just go back to this. He has just explained this TP, TN, FT, TP, TN, FP, and FN. Correct? False negative is also called as type 2 error. The model wrongly predicts the positive class. In the above example, 8 people who have tumor are predicted as negative. FN is also called as type 2 error. Correct? With these 4 values, can we generate TPR? What is TPR? TPR is nothing but TP divided by actual positives. Are you getting this, guys? TPR, how do we generate? So TPR, so if I have to generate TPR, correct? In the numerator, what should I take? Just take TP.
True
Where is your
positive.
TP? 241.
241.
Divided by, in the denominator, what should I take, guys? It is TP plus FN. Where
241
is your
plus
TP?
193
Yes, 241 plus
193.
193. So when it comes to your true positive rate, it is around 56%. Guys. This is your true positive rate. Is it clear, guys? True positive divided by actual number of positives. Then you have formula for false negative rate, true negative rate, and false positive rate as well. Now, more than this, I would see this. You anyway have a formula for false negative rate. Also, you have formula TNR and FPR. Also, you have a formula. But more than this, I would like to draw your attention to how to calculate precision and recall. Right. So this, please try to understand. Both precision and recall are crucial for information retrieval, where positive classes matter the most as compared to negative. So in our cases, positive classes matter as compared to negative. Do you agree? Churners matter more than non-churners. For example, unhealthy patients or sick patients matter more than healthy patients. So precision and recall always matter. While searching something on the web, the model does not care about something irrelevant or not retrieved. This is true negative case. Therefore, only TP, FP, FN are used in precision and recall. So he says that true negative itself is not required at all. TP, FP, FN are required. So how do you calculate precision? Precision means out of all the positive predicted, what percentage is truly positive? So precision, if you have to calculate, it is simply TP divided by TP plus FP. So if you have to calculate this value precision, it is TP. Where is your TP? It is 241. 241 divided by TP again plus FP 138. This is your precision, guys. TP divided by, right? Are you able to understand? How do we calculate precision? Even if you remember the rest of the things, just remember what is TN, what is FP, what is FN, what is TP. Then how do you calculate the overall percentage accuracy, which is nothing but sum of the diagonal elements divided by the overall percentage of accuracy. Precision is nothing but 64%. Now, where is precision to be used, guys? Where do you think I need to use precision?
The medical analysis, like analysis for COVID, non-COVID, or the images are those kind of very crucial.
Yes, wherever you want to penalize false positives, that's when you need to use precision. Yes, I want to punish false positives, right? Isn't it? I don't want too many false positives. I'll just give you an example. Let's take two cases into situation, right? One is basically your mobile manufacturing, correct? Every day, basically, there is a lot inspector and he makes multiple mobile phones, correct? Let's say he makes 1,000 mobile phones. He delivers 1,000 mobile phones. The machine delivers 1,000 mobile phones. I want to find out. I want to find out whether some of these mobile phones are defective or not. There are two decisions that I can take, right? Actually, the mobile phone is good. By mistake, I'm just calling it as a defective product. The mobile phone is actually good. But what am I saying? It is bad. It is bad means basically it may not see the daylight. So it will just all the cost and such things that you have sort of incurred while manufacturing that mobile phone is gone. So you are wrongly sort of classifying a good mobile phone as a defective product. What is this a case of? Isn't it a case of false positive? Falsely, you're calling it as a defective product, which is a bad thing. And therefore, I want to penalize this. If you want to penalize this, you can just use your precision. Next case is basically, you look at recall. Out of the total positive, what is the percentage? What percentage are predicted positive? It's the same as TPR. So to recall, just look at this formula, TP divided by TP plus FN, which is TP is 241 divided by TP plus FN. FN is nothing but 193. Am I right? This is around 55%. Are you able to understand? The overall percentage of accuracy may be on the higher side, which is 81%. But more than the overall percentage of accuracy, please look at the precision and recall. Now let's just look at this credit card fraud detection. Like he's just given an example of credit card fraud detection. Please read this. Right? Please read this. In fraud detection and such things, we don't want to miss out even one single fraud, correct? I don't want to miss out one single fraud. Therefore, we want the false negatives to be as low as possible. Correct? In these situations, we can compromise with the low precision, but recall should be very, very high. So if the business says basically that I am willing to compromise on one thing, but not on false negatives, we can't have too many genuine cases being called as fraud cases. Therefore, we want false negative to be as low as possible. So wherever you want the false negative to be as low as possible, you can go with recall. Typical example is basically fraud detection in credit card industry. Is this clear, guys? Read this second sentence. In a medical application, we don't want to miss out any patient. Therefore, we should have a high recall. So far, we have discussed when the recall is important than precision, but when is the precision more important than recall? So are these two cases clear, guys? One is fraud detection and medical application, wherein we do not want any patient to just miss out, correct? So under these circumstances, recall is important. Right? If you want the false negatives to be low, if that is the business goal, that I want the false negatives to be as low as possible, then we can use recall. When do we use precision? Look at this example, spam detection. Spam detection is a typical example where we want high precision. In the detection of a spam mail, it is okay if any spam mail remains undetected. But what if we miss any critical mail because it is classified as spam? In this situation, false positive should be low as possible. Here, precision is more vital as compared to recall. So if you want the false positives to be low, look at precision. Is this understood, guys? Yes, no?
Yes, sir. Yes, sir.
Yes. All right. So two main ideas that you need to keep in mind is what is false positive, what is false negative, what is true negative, what is false positive, right? Based on that overall accuracy, how do we derive? When is precision important? When is when is recall important? Correct.
Recalling.
So yes. So you can just see the formula here. Precision is equal to TP divided by TP plus FP. Recall is equal to TP divided by TP plus FN, right? And you also have somewhere F1 score as well. I saw somewhere F1 score formula also here is given. No, F1 score. Yeah, this is F1 score. Just see here. F1 score is nothing but the harmonic mean of the precision and recall. It is this just the harmonic mean, which means 2 times precision multiplied by recall divided by precision plus recall will give you the F1 score. It is a weighted average of these two things. Usually we either pay attention to precision or recall. If you want both or take a weighted average of both, you can look at the F1 score. Is this okay, guys? Are you able to understand, guys? Overall confusion matrix. Guys, any confusion? Ganesh, are you able to follow this?
I can follow, sir. Yes.
Yes, Nidhi. Ajaz, are you able to understand this? What we're talking about?
Yeah, I'm catching up. Yeah.
Amit, Krishna, Anand.
Yes.
Okay, shall we just break for tea and come back?
Sure, sir. Yeah.
Sir,
Yes, please.
one more question. So I'm
Yes.
sorry. See,
No, it's Anand. Please go ahead. Yeah.
right. So if I'm not wrong, there is two more parameters there. It's good that we discussed. It's really nice. I like it. And it's very. In fact, some of my doubts again got cleared for precision recall and F1 score. If I'm not wrong, there are two more parameters, or I mean, yeah, two more factors there. Like one is specificity and sensitivity.
Oh, yeah. Sensitivity and specificity. Right. So more than sensitivity and specificity, what is the industry norm is sensitivity and specificity are used to generate ROC curve. And based on the ROC curve, again, you can find out whether the model is good or bad. So if you want to specifically identify sensitivity and specificity, after break, maybe we can just talk about it.
Right, sir. And ROC. Thank you.
Sure, sure.
And AUC, area under the
Yes,
curve.
area under the curve. Yes.
In which scenario we should consider F1 score?
I don't know if you're talking to me or you're talking.
I'm talking to you.
Nidhi, what is the question?
You were not quite audible.
Yeah.
Maybe you can come closer.
I was asking in which scenario, like in which particular stream or domain we should consider F1 score, like for medical industry or like credit card, we should go for a recall.
Yes, so that's what we were.
Similarly,
Sorry. Nidhi, if you just look at that, if you look at this blog, I can just send this blog to you, right? So here he says clearly, are you able to see my screen firstly?
No, sir.
you stop sharing.
Yes, sir.
Are you able to see this?
Yeah,
Yes,
now
sir.
So in which your question is basically in which scenario, what should I use? Correct?
yeah.
So as a general rule of thumb, rule, if you're doing credit card fraud detection, if you're doing credit card fraud detection, or if you're in healthcare sector, for any of these two things, right? What we want to do is, look at this. He says in these situations, we can compromise with a low precision, which means I am okay with low precision, but my recall should be very, very high. So this is the answer to your question. You can focus on recall mostly in the healthcare sector and when you're doing specific problems like fraud detection.
Yeah, that I understood. I am
Yes.
asking about F1 score. Where should we consider F1 score?
Where you should consider F1 score. So there is no clear answer there because we are giving specific weightage here. Usually more than F1 score, people usually prefer either precision or recall. I can't think of a specific example wherein they focus only on F1 score ahead of these two things.
Because of what, why I'm asking, because in F1 score, precision recall, both are given importance. So there
Where?
could be some scenario where like both the things should be in a like a hand to hand, or some sort of balance should be there in both the
Yes.
cases, precision recall. So that is the reason I was asking.
So let's just look at this. It is a harmonic mean. It takes both FP as well as Fn into account. Therefore, it performs well on imbalanced data sets. F1 score should gives the same weightage to recall and precision. F1 score per se will give the same weightage to recall and precision. He says there is a weighted F1 score in which we can give different weightage to recall and precision. As discussed in the previous section, different problems give different weightage to recall and precision, right? So he has not specifically said any area here for precision.
Okay.
He says basically this is the weighted F1 score. He says beta represents how many times recall is more important than precision. If the recall is twice as important in precision, then the value of beta is 2. That's what he says.
Mhm.
Right? If the I can't think of any specific example where they use precision. I think it is a customized thing wherein if you feel that for a specific area you want to give twice the weightage for recall as compared to precision, maybe you can use this. But it is a individual discretion rather than a domain specific thing.
Okay.
Any questions, Ganesh? We'll just break for coffee and come back to this.
Okay, sir.
So is today last class for statistics or we have another class next week? Or how many classes left? Anyone knows?
Amarnath, I think so. This might be the last class. I'll confirm with sir and I'll let you know.
Okay.
Some model diagnostics are clear, guys. Any clarification needed? Just two things: overall accuracy, how to get it, precision, recall, when to use what. I think if you are able to do this, I think it should be fine. Good enough. Guys, are you back?
Yes.
Yes, sir.
Yeah, back.
You're able to get this, right? So do you want me to go through this once again, like at a very high level, what we did? Logistic regression, when is used, when is it used, what is it, right? At a very high level. After that, there is a small piece of code which I want to run for linear, which I sort of didn't run last week. I can just finish it off. One small piece of code, right? So
Sir, will you be explaining that area under the curve also?
yeah, I can just show you.
Okay.
Right. Can you see my screen, guys? Everybody, at a very high level, I'll just explain. I think some of these things are self-explanatory. Right, importing packages, importing the file. Three main
Sir,
problems.
I cannot see your screen now.
Sorry?
A screen is not
Your
visible.
screen.
Now is it visible?
Yes, sir.
Yes,
Okay.
sir.
So we have basically imported the packages, imported the file. Visualize, guys. What are the three main problems? Dependent variable or string we use. We have to convert it into numbers. Independent variables are mixed data types. Some of them are numeric, others are basically object type. Correct? That's the problem. Second is basically missing values can add further to the problem. Correct? So what did we do here? We explored the data, we checked the shape of the data, size of the data, as well as we just displayed the preview here. Then we scroll down. What did we do? We checked for any null cases and such things. pd.null function, pd.is null of data frame dot any. Right? It can't detect blank cases, only NA cases it detects. NA or NaN, right? So we had a bit of a problem with the variable what? So pd.is null of will display 000, right? But when you run df.info, right? Also, you're getting, when you look at total, monthly charges and all, you'll be getting 7043. When did we actually run into a problem? When we try to convert the object, right? For example, here, total charges. Can you see this option here? The 19th variable total charges is a object. Object means it is basically categorical, which is not categorical. Why is it reading it as categorical? Because it has few numbers and few blank cases. Correct? So straight away it is putting it as a object. So that object we have to coerce into numeric. So what did we do? We just use this function pd.to_numeric. Convert this into numeric. Errors is equal to coerce. Correct? We literally forced it, and then we use the mean imputation to impute for 8 blank records. Are you able to understand this? 8 blank records. So missing value analysis. Then we reran the data.info. Correct? df.info. When I reran this, I was able to see that 19th variable total charges is no longer object. It is converted into a float. Are you able to understand this so far? Scroll further down, look at the describe function, check the distribution of the dependent variable. Non-churners, how many are there? Churners, how many are there? Now here is where we transform the dependent variable into a numeric variable, right? 0 and 1 we were able to sort of introduce because original data was in the form of non-churners and churners. Then we have df.head, df.info, correct? We created a new variable for the dependent variable, we called it as y, which was numeric, no longer string, right? What is the trick that we perform? Label encoder. Please use label encoder function. Label encoder function, and then you can just use le.transform, pass that variable name, it should be converted to a numeric variable. We have taken care of the numeric. Now our attention was focused on the independent variables. We have few numeric variables that is not disturbing us, 4 independent numeric variables. I kept that separate. Now separate out the independent variables for conversion into numeric. If you look at gender, partner, dependents, phone service, multiple lines, internet service to online security, all these are what kind of variables? They are all categorical and string. We need to convert them into numeric. So for each of these, I can't use this transform function that is present. So what did I do? Get dummies function. OK, I used get dummies function, correct? You can see here. What did we do? OK, dot lock, we use separated out the numeric variables, called it as x underscore num. Then we use the get underscore dummies on x underscore categorical. What does this do? It converts the entire categorical variable, which is in the form of words, string, character, whatever. It converts it into numbers. Correct? I have x underscore num and x underscore num1. So we were able to concatenate it and generate the preview of this file. Correct. Actually, the objective of this exercise was to give you good exposure in pre-processing and post-processing this. So therefore, you saw around 1.5 hours we actually spent in pre-processing steps itself. Were you able to appreciate this? Why did we do this? In Boston Housing, we did not do much pre-processing, right? Some heat map and such things we constructed, but not this level of pre-processing, correct? So all these things are important. Now this is the end of pre-processing. Then it's a regular exercise, train underscore x, test underscore x, 75% training, 25% test, whatever, blah, blah, blah. Then we check for the null cases. So before you run a logistic regression, make sure that you don't have any null cases. You should not have one single missing values. Missing values are a big problem. You'll run into a lot of trouble. Then make sure that you're checking the size of the data set, right? If training underscore x has 5082, then training underscore y should have 5082. If one of them has missing cases, your model will not run. You'll get into a lot of trouble. Test underscore x, 1761 here, 1761 here. Then it's a simple case of fitting the regression model, right? Which is what we have done, right? Log dot fit logistic regression, then log dot coefficient underscore, right? In fact, it is, yes, this will generate the coefficient. We sorted it, pasted the variable, right? And then the third part is the post model, pre-processing and post-processing. After this, what did we do? Basically, we generated the confusion metrics, correct? We generated the overall accuracy of the metric, correct? Metrics.accuracy.score, confusion metrics we were able to display, right? I took this in Excel and explained each and every number if you recall this, correct? What is true positive, what is true negative, what is false positive, what is false negative, correct? Identify these four numbers, correct? And then identify what is the accuracy metric. From there, you can either get precision or recall, not either. In fact, you can get both precision as well as recall. And then your F1 score is nothing but, 2 into product of this divided by something, right? It is nothing but a weighted average of this, which is a derived metric from this. Are you clear with this? So far, any questions, guys? Are we good? Any questions, guys? Okay, can you just open that Boston Housing, guys? Just for a quick moment. Last week's code, if you have, just open up that code.
Okay.
You see my screen, guys? I think we had generated the coefficients and such things, and we had sorted the values, correct?
Yes, sir.
Just tell me if you are at this stage.
Yes.
Okay, just give me one moment. So this is one way of generating the coefficients. So this is method 2. Method 2. Generating linear regression output. Right, this is just a quick and dirty way of getting the regression output case. Right. So for this, what we will be doing is, right, as before, we can just use this stats model. Stats model.formula.api. Okay. Stats model.formula.api as SMF. Try to rerun that Boston housing, all the codes, because the packages and have to be sort of imported again, right? Stats model.formula.api as SMF. Clear? Now, what we are going to do is directly build a linear regression model by using a simple function. Can you see this? So here we are just calling it as SMF. That SMF.OLS. Housing price is your dependent variable. Put a tilde symbol, and then you have to enter all the variables which you want to take. Put a comma and then specify data is equal to the name of the data set. SMF.OLS. Here, the advantage is that in just one line of code, you will be able to generate the results. Data is equal to Boston underscore df dot fit off. At the end, you're just culminating by say dot fit off. Right or left? smf.ols. Your copy. Right? Right. Just save this as a model. Okay. I'm just saving this. I've also sent the code to you guys. Now you can say print of model.summary. You can just see it. This is the model we have generated. Dot summary function. If you use, you'll get all the output you can see here. In one shot, you'll get all the output. In one shot. You can look at the probability value to decide whether it is important or not, because those variables which are with a p-value less than 0.05 are important, and those variables which have a p-value bigger than 0.05 are unimportant. Aditya, getting it?
Sir, can you explain this again?
You want me to explain the code or the output?
On the output only.
Yeah, just 1 second. Let me just let others finish. If all of you are finished, I don't mind explaining this case. Correct. So please look at this, guys. Everybody, housing price is the dependent variable, and we are trying to use predictors like crime rate, variable Zn, Indus, whether Charles River is flowing or not, nitric oxide, rooms, age, distance, rad, tax, pupil to teacher ratio, beta, not beta, sorry, but percentage of black population, and L stat is nothing but your percentage of lower strata in population. Now let's just look at this OLS regression result. All right. First thing that you have to focus now is what is called as R square. Now I would appreciate if you answer rather than me answering everything, guys. One of you should take the lead and just drive this, because you have done this, I don't know, around 10-15 times. I would have explained what is R square.
Sir, before going to R square, is it that all the variables in the OLS on the right hand side are all categorical?
No, they're all numeric. They're all numeric.
Because I remember something similar from ANOVA.
So this has got nothing to do with ANOVA. This is a different data set. This is a completely different data set. All of them are numeric variables.
Okay, so I was thinking about that, if housing price, as you told there, so like a scale and then categorical.
Housing price is scale. The others are also scale and numeric.
Okay, and here also I don't see any interaction variables.
No, there's no need to specify interaction and such things.
Okay.
Guys, firstly, let's look at the output. Guys, can somebody take the lead and explain this output, guys?
I can do that.
Anybody?
Yeah, so the R square here is talking about the predicted outcome and the actual outcome difference. So the variability is like 74% explained. Adjusted R square here again, the same thing. Seems like all of the variables have some importance, and there's none that it's taking as an extra. So it's coming nearly same. I think adjusted R square is 734. So it's nearly same as R squared. F static is just a number, but we'll look on the p-value of it. So which is minus 135. So it is uh, okay, I don't know what to say about this overall F static and the p-value.
Okay, anybody else, guys? Guys, only 2 or 3 things that you need to keep in mind. First point that you need to keep in mind is the model good or bad? Am I right? For anything and everything, we always speak about model good, whether the model is good or bad. For logistic regression, how do you assess? Today you learned that it is overall accuracy. Right? If the accuracy is close to 1, we got 0.82, accuracy lies between 0 and 1. If the accuracy level is greater than 70%, the model is good, or else the model is bad. Here, what do we have? We have model goodness of fit, which is called as R square. If you say R square is fine, I mean, I don't see a lot of people will just be able to say R square, but please use the correct nomenclature. This is coefficient of determination. I've said this earlier, boys, you should say the correct terminology. R square is nothing but coefficient of determination. 0.741, which means R square always lies between 0 and 1. 74% of the variation in housing price of Boston is explained by variables like crime rate, percentage of land zoned, industrial location, blah, 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 Charles River, nitric oxide, so on and so forth. So the independent variables that you have taken, 74% of the variation is explained. Remaining 26% is not explained. That one statement you should make clearly is. Quotient of determination, you should be crystal clear with that. You should be crystal clear that R square is quotient of determination, and it lies between 0 and 1. Greater than 70% is always good, less than 70% is always bad. Now you can also look at adjusted R square. Adjusted R square comes into picture when you are comparing between two models, or else it is of not much use as such. Then you have the probability of F value, which is 6.7 into 10 to the power of minus 35, which is smaller than 0.05. Correct? If it is smaller than 0.05, it means that R square is significant. If it is greater than 0.05, it means that this model, the model fit and such things are not reliable. You can't take it seriously. So far, we are clear. To talk about the quality of the model, I'm using R square and the P value. Now let us just come down to the nuts and bolts. Let's look at some of the variables here. Crime rate, ZN, Indus, CHAS, and all these things. These are the coefficients produced to this. I explained it yesterday, not yesterday, last week. NOx, nitric oxide. Nitric oxide is a lot easier to explain, right? Nitric oxide means basically we said pollution level. If pollution level increases by 1 parts per million, then the housing price comes down by $17,000. Are you clear with this? Right? Let us look at another variable, like let's say LStat, percentage of lower status, lower strata of people. If that increases by 1 unit, then the housing price comes down by 0.52 units. More than all these things, I would again look at the p value. Can you see the p value here? The heading is p value. So p value is reported for each and every column here. If the p value is less than 0.05, it means that that variable has a great impact on the dependent variable. If the p value is bigger than 0.05, it means that such a variable does not have any impact on the dependent variable. So for example, if you look at crime rate and such things, 0.001 clearly less than 0.05, so it is important. Next, 0.001 less than 0.05, so important. Indus 0.73 greater than 0.05, so it is not important. Look at this variable 0.958 greater than 0.05, so it is unimportant. All right. So this is the confidence interval that is reported here. These are certain additional statistics that we have generated, but mainly for this module, just focus on the coefficient values, the p value. You can also focus on the R square. One thing that you can do is, because the p value is less than 0.05, you can just rerun this model. for some of these variables. You can just copy and paste this here. Right, look at this variable 0.738, that is the variable indus and age. They are not important. So drop this variable indus and age. Let me just remove this variable indus. And I also don't need the variable age because the p value is bigger than 0.05, which means that they don't have an important impact. Let me just run this again. Run a print of model.summary. Are you able to understand this, guys? So this is a very simple way of generating the coefficients and everything. If you look at the earlier output, see, this is, we did a lot of work here, right? We split the data, training, testing, right? Then we generated the coefficients and such things. This is another way of generating the coefficients. Yes, in so far as questions are concerned, I've already told you guys, two parts, part A and part B. Part A will be usually theory, not too much of practicals. Whatever we have covered, if you've been sort of attending my classes regularly, I don't think you should find it very difficult, right? So focus on parametric tests versus non-parametric tests. The 5 tests, t-test, t-test, right? One sample, independent samples t-test or A/B testing, paired samples t-test. We spoke about Pearson's correlation, Spearman's rank correlation, ANOVA we've spoken about one way as well as two way. Please go through that. And then what did we do? We did chi-square test of analysis. For relationship, what do we do? Either chi-square or correlation for comparing the t-test. Then we did multivariate analysis. Two techniques we saw. One was linear regression last week, and today we focused on logistic regression. What are the model diagnostics that we were able to look at? Correct. Model diagnostics, please pay attention to it. What is FP? What is TP? What is your overall accuracy? How do you decide on this? That is very, very important from an examination point of view. From an interview point of view, the entire procedure, I don't think you can go beyond what we have gone as far as the pre-processing and such things are concerned. By and large, I mean, here and there could be some this thing, but by and large, I would say that we have covered the pre-processing part extensively. Why? Because that is so important for you rather than just taking a quick model. I can take a data set with 4 numeric variables, build a model and say job well done. Right, but it was not of any use to you, and therefore I deliberately took a data set which is slightly mixed, complicated, and we were able to do the pre-processing. Right, from a Python code perspective, how do you get dummy data, dummies? How do you create dummy variables? Second one is basically your, what is that? Label encoder. That part is very, very important, right? ANOVA, one question definitely will ask. You can't you can't have a statistics class without them speaking about correlation and ANOVA. Right? Missing values, we have just dealt with this today. Correct? Part A will be this. Part B will be one case study. It could be based on linear regression or logistic regression. Aditya, clear? Any doubts? Any doubts, please ask.
Yes, sir. I have few questions on it.
Please.
Yeah, just wanted to check. Let's say my model accuracy was not perfect, and I just get this model summary details, and now I have to draw few variables to get proper values, or maybe some variables are not required. Then how should we drop those dependent variables?
Independent
Sorry,
variables are
independent. Yeah, correct. Independent.
So there are two things here. You are saying model accuracy is less, therefore I have to drop variables, correct?
Yes, correct.
So if the model accuracy is less, dropping variables will not help you. If the model accuracy is less, you have to change the algorithm. That's what it means.
Okay.
Right, you have to do a bit of pre-processing and such things, and then make sure that the data set is at least good enough or decent enough for you to improve the accuracy. Usually that does not work. So change the algorithm. Some of the alternatives for logistic regression would be decision tree or random forest or support vector machine. Any of these techniques can be used, or a combination of two techniques can be used, which is called as ensemble modeling. Ensemble techniques and such things will be taught to you in detail at a later stage by different speakers.
Okay.
So here my goal was to set the platform by talking about what is linear regression, logistic regression, hypothesis testing, p-value, what is false positive, what is true positive. That is the purpose behind it, right? So all those questions, if you have certain questions, please keep them handy, because after this you'll have other modules as well wherein they will discuss in depth as to how you build a decision tree, what is random forest, what is the meaning of CNN, what is neural network. We are getting ahead of ourselves now at this stage. So to your question, dropping variables will not really help me boost accuracy in a big way. You at best can change the techniques.
Okay. So so last week you have given the car sales database data. So there I just apply the similar kind of approach, linear regressions. There I got the MSC around 5,422.
If you remember, we discussed that MSC is not something which you should go by. You should go by R square.
Okay.
More than MSC, I'm happy that you have obtained MSC, but don't pay too much of attention to MSC. You have to trust R square in the case of linear regression.
Okay. Okay.
Okay. And then next week is the test, right?
On Sunday, right?
Yes. Guys, Sunday. What test will
Saturday,
be there?
right?
Yes, Saturday. Guys, I was hoping that if you have completed this linear regression, I could give you one more assignment. Because 2 assignments and 1 exam is what you're supposed to take.
Please give it.
Now, you have to tell me I can give you one assignment, but then you'll be focusing more on the assignment. You'll have lesser time to prepare for the exam. So after this exam, will you be in a position to sort of give me the old this thing? You anyway complete. I'll just give you the assignment, but you take this 1 week to study to prepare for your exam. After the exam, 1 more week you will have. You can just focus there and give me the assignment.
Sure, so that works well. Yeah. Yes, we can do like that, I guess.
Right?
Yes, sir.
I don't want to pressurize you by giving you assignment as well as this. I just do one thing, right? I believe that doing one thing is better, right? Focus on the examination for the next 7 days. And because of that preparation, I think assignment will help you. Assignment delivery will be a lot easier for you, right? So what you can do is basically, I will give you a data set which is called as a bank loan data set. Sorry.
Sir, can I ask one more question on A/B testing?
Yeah.
Okay. So on few of the websites, I have read about that they say the second group has no significant improvement as a null hypothesis. Is it right to say like that?
Second group has no
significant improvement.
So null hypothesis is that second group has no. Yeah, you can take it like that also. No problem.
So, sir, it has got two different meanings. So one is like there's no relation, then it's like neutral. But when I talk about saying improvement.
See, the question of relationship and such things does not come into picture when we are talking about A/B testing. A/B testing is used to compare the performance between two groups.
Right.
So that question of, there is no relationship, that itself is does not come into picture. So A/B testing at best, if you want to do a good job, something which is simple, non-controversial, straightforward, and an easy way, null hypothesis is that the two groups have no difference in performance. Alternative is that there is a difference in the performance. Alternative hypothesis is that there is a difference in the performance. Then you do the A/B testing or independent sample t-test and look at the p-value and conclude accordingly. So this entire thing about relationship that you're talking about is not, it will not be addressed by A/B testing in the first place.
Right, sir. But when I take the wording says has got no significant improvement.
Yeah, so
this was like
no significant improvement. That is your null hypothesis.
Yes.
Yeah, so if you are, I think he might have taken this because he believes that the second group is expected to show some improvement.
Yeah, but in real
He is
time,
very confident that the second group has to show an improvement.
yeah, but then it is wrong, right? Because it can also decrease the performance, right?
It can decrease, but if you're short that the baseline model is not at all good, then you can take this also, right?
Okay.
That's where your empirical knowledge comes into picture. See, right now I'm not doing any, I'll give you my own example. Let's say campaign analytics, correct? So right now they're not using any mathematical model, nothing. Now I'm here saying that mathematical model I'm proposing. What do you expect? The mathematical model should outperform a no model, correct? A scientific model is expected to outperform or at least be the same as that of the old model. It can't be worse than the old model because you did not have anything before this. So if you are dead sure that the new variant is better, if you empirically, I'm using the word empirically because based on your common sense, based on your domain expertise, if you believe that the new variant has to be better than or at least equal, it can never be worse than this, then basically you can frame the hypothesis like that.
Right. So, sir, last time you have asked that for our own practice, we can try to perform some A/B testing on the sales and price, depending upon the type, right?
Correct.
Yeah. So
So
I
you'll be
did
doing
that.
two types. So type is a binary variable, correct?
Yes, 0 and 1. So
yes.
only two unique variables.
Correct. So first basically you take the variable sales and do a A/B testing.
Can I share my screen?
I'm sharing the screen already.
No, can I share my screen?
Yeah.
Okay. So this is what I tried.
You're showing me
so
ROC
this was
curve.
for the no. Okay. I
I'm
think
able
I
to see
shared.
Teams now.
Okay, I'm sharing it again.
Sir, actually, we are supposed to look into ROC and AUC. Can we go through that first, then we look into anything?
No, we just finish off this first. I think otherwise we just never get through this.
Yeah. Can you see the screen now?
Yeah.
Okay. So the first one was on the type and the sales. And then I just tried to write it as has no significant improvement. But then here
there is
the
no significant. Yeah, what you have done is correct. Yeah, it makes sense. What you have done is correct. You're showing me the p-value. So there is no significant difference in the sales for the two types of vehicles. That is correct. Then you have to again do the same thing, copy paste the same code. But wherever you're typing sales.mean, you have to type mileage, mpg.mean. That is the second type of A/B testing you're doing. This part, so what you're showing me in line number 54, 57 is correct.
Okay.
Correct, but you have done this for sales. Keep this output. We need this also. But next, what you have to do is copy paste the same code and instead of sales, replace the word sales with mileage per gallon. That's what you need to do. Your job is done.
And second, I try to do it with price.
Okay, fine. Price you have done. Okay.
Yeah. And here also, here I didn't put because the p value was 0.59.
Are you sure this is correct? Firstly, the code itself looks suspicious to me. T-value, p-value, stats of type equals 0, price, comma. Okay, it looks fine. Okay, so there is no difference. There is no difference in the price for the two types.
No.
But you have to check. You have to check your code. I feel that there is something suspicious in this code. I'm still not sure whether you have written it properly for line number 55 that you're showing.
No, it's right only. It's the same 57 length code and then modified for the variables.
No. What is the average price for 0 and what is the average price for 1? I am not able to see that.
Okay, here I try to get it. Sales and price. So, no, okay, I have not divided on basis of that. I will have to calculate that. But then, and here for those empty strings, I just removed the records and I have not done any imputations.
That's okay. I mean, because I don't think you have too many missing cases, but I need to see clearly what is the average price for type 0 and what is the average price for 1. And I'm 100% sure that there is a difference. So please check your code once.
Okay,
please check your code. So line number, this is a bit suspicious.
Okay. Okay, sir, I will check it again, but then this is what I was getting, so thought
No, it's wrong. It is wrong because it can't be the same. I have worked on this data set. I remember getting different results for this. So this is not correct. There is something suspicious. I can understand for the first one, it is still looking meaningful. Something sensible is happening in the first one. In the second part, line number 55, I'm highly doubtful.
Okay, sir. I will try to rerun this again, and this time I will take the means also.
Okay, guys. This is the data set, guys. I was just talking about the assignment part. Guys, these are some of the independent variables that you have. Typical bank loan, this thing, wherein 1 basically means that a person has defaulted, 0 means he has not defaulted. You have some demographic details, also some derived variables, right? Age is there, education level is there, employment years with the current employer is there, address is there, income is there, debt to income ratio is there, credit card debts, credit to debt ratio is there, other debts is there, whether a person has defaulted or not. So you have to use a simple logistic regression model. Right here, there is not much of pre-processing because everything is numeric. It's a lot easier in one line. You can actually write. Right, everything is simple here. So can I just share this data set for assignment number 2? Right.
Yes.
15 days time you have. I think it should be pretty simple. Coefficients. What is your interpretation? You can just give. Okay. Anything else, guys? Guru, you're okay? Aditya? Anish? Okay. Slightly, I know it was extensive today, but I couldn't help it. We have to go through this, right, at some stage. Right. I initially, to be honest, I thought of doing with bank defaulters. Within 5 minutes, you'll get the results but that is not how you get the data in real world. Right. So please bear with me. Okay, guys, shall we close for the day?
So one last minute thing. Need consensus from others also. So generally, like we prefer the exam to be done on a Sunday because like we'll get that extra one Saturday for preparation. If you and others are in agreement, can we look at doing it on a Sunday first option?
When you say you, are you referring to me?
Yes.
No, I'm okay any day. I mean, I don't know whether program office will be okay or not.
We have been doing it in the past. Would like to hear from the other friends as well.
Guru is saying Saturday will be best. Srivalsa is saying Saturday is best. Pranish, Saturday?
Sunday.
Aditya?
Sunday better.
Sunday better.
Sunday, because Saturday at least.
Ganesh, you're in the minority. Sorry.
No, others are also not talking. That way I become the minority.
Sorry. Unless you're able
hearing
to
Amar,
convince.
Nidhi.
Okay,
Unless
for me,
Sunday is better.
For me also Sunday works well.
Okay, three
Yeah.
people on your side.
Sunday is
And
fine.
Nidhi
Saturday
also
is
Sunday
working.
winter.
Nidhi said Sunday, is it?
I have guest at my
Yes.
home, so even the Saturday, Sunday will not work for me. But okay, I'll have to